In this video, we will see some questions based on combination. So, first question is about it says a music director needs to form a band of 8 musicians from a group of 11 musicians. However, there is a condition that says two musicians A and B have different music styles and refuse to be in the same band. So questions is how many ways can the music director form the band if A and B will not be in the band together? So we will see the solution for this. So we will see with two different approach. Okay. So about first approach, so condition is A and B will not be in the same band together. So what we will do? So since we can do if we will subtract total ways of selecting people to form the band. If I will subtract when A and B are when A and B are in the band. Fine. So this is the required ways. So this is the one way of solving this kind of questions. We will simply see what is the total number of ways and we'll subtract when A and B are in the band. So okay, when A and B are in the band together, actually we can write here together as well. So question is there are total 11 musicians and we have to form a band of 8 musicians. Okay, so okay. So we know in how many ways we can select 8 people out of 11. We can do in 11C 8 ways minus. So we have to focus here. We are saying A and B are already in the band. So what we have to do, since A and B already are in there, and we have to form a band of 8 people. So A and B are already are there. That means we have to select 6 people out of remaining 9 people. So that we can do in 9C6 ways. So what we have to do, basically we have to solve this part. So it will be we have to just apply the formula of factorials, combination 11 factorial 8 factorial in 11 factorial divided by 8 factorial into 3 factorial minus 9 factorial divided by 6 factorial into 3 factorial. It's 9 factorial divided by 6 factorial into 9 minus 6 factorial, which is 3 factorial. So if we will solve, we will get 11 into, I can write 11 into 10 into 9 into 8 factorial divided by, I can write 8 factorial, and 3 factorial I can write 3 into 2 into 1. Then this part will be 9 into 8 into 7 into 6 factorial divided by 6 factorial into 3 factorial. I can write 3 into 2 into 1. Okay. So 6 factorial will get cancelled out, and here 3, it will be 3, and it will be 2 times 4 will be 8. So it will be 4. Now similarly here 8 will get cancelled out, 8 factorial will get cancelled out, so it will become 3 and it will be 5. So now we'll get 11 into 5 into 3 minus 3 into 4 into 7. So it will be 11 into 15 minus 12 into 7. So it will be 11 into 15, it will be 165. Okay, and 12 into 7 will be 84, which is nothing but 80. So which is the answer for this. So this is very simple approach. Condition is that A and B will not be in the band together. So what we will do, total ways minus when A and B are in the band together. Okay, so now we will see the second approach and we'll cross check whether our answer is correct or not. So second approach we will start like so second approach will be like this. So condition is A and B will not be in the band together. So we will see the possible cases when A and B will not be in the band together. So what will be the case? One case will be like this. Suppose A is in the band and B is not. Okay. Another case will be okay. So I can write A is not in the band and B is there in the band. So we have to satisfy this condition. A and B will not be together in the band. So another case will be when both A and B are not in the band together. Okay. So in these three conditions, A and B will not be together in the band. Whether suppose here A is there but B is not. So A and B both are not there. A is not but B is there, but again you can see both are not there. And last case when A and B are not there in the band. So in how many ways we can do, since we have to form a band of 8 musicians out of 11, we are saying A and B are not there and we know B is not there already and A is already there. So what we have to do, since 2 will be minus, so what we have to do, we have to, so here it will be 9 people. 9 for, we know B is already not there, but we know A is already there. Okay. So that means out of remaining 9, A is already there. That means I have to choose 7 people. Okay. Because anyway we have to form the band of 8 people. So A is already there. So I will choose a 7 people out of 9. So it will be 9C7 plus same for here. A is not there. Okay, but B is there. So again B is there, so I have to choose remaining 7 people out of 9. So it will be 9C7 plus here when A and B both are not there. So that means A and B already are not there. So here it will be 9 people and I have to choose all 8 people out of 9. Okay. So now we have to solve this part. So this both will be 2 times 9 choose 7 and it will be 9C8 and it will be 2 into combination formula we have to apply, because we know NCR is nothing but n factorial divided by r factorial into n minus r factorial. So it will be 9 factorial divided by 7 factorial, 9 into 7, that is 2 factorial, plus it will be 9 factorial divided by 8 factorial, and 9 minus 8 will be 1 factorial. So we have to just solve this. It will be 9 into 8 into 7 factorial divided by 7 factorial into 2. So 7 factorial will get cancelled out, 2 will get cancelled out here, and it will be next it will be 9 into 8 factorial and 8 factorial into 1. So 8 factorial will get cancelled out here. So it will be 9 to say 8 72 plus 9, which is 81. So which is the answer, same as the approach one. Okay. So we can see with the approach 1 and approach 2 we are getting the same answer. Okay. So now we will see the second question. So second question says a box contain 6 red, 4 white and 5 black balls. Okay. So let's see solution of this question. So a box contains, suppose there is a box something like this, and it contains 6 red, 4 white and 5 black balls. Okay. So a person draws 4 balls. So person draws 4 balls. Okay. He draws 4 balls from the box at random. In how many ways among the balls drawn there is at least one ball of each color. Okay, so condition is there should be at least one ball of red color, one ball of white color, one ball of black color, something like that. It shouldn't be like that. We have selected two white, two black, or three black, or one white, something like that, because here red ball is not there. Okay, so we have to choose such that at least one ball of each color should be there. Like cases will be one red, it can be one red, one white, and remaining two are black. Or okay, so how we can do like this? So let's see the cases. So required weight will be, so at least one ball, and in total we have to draw four balls. So let's say one red ball, okay, one white ball, and remaining two are black ball. So you can see there are total four balls we have drawn, and at least one from each color. Okay, plus another case can be one red, okay, let's say two white and one black, okay, plus another can be two red, one white, one black. Okay, this is the possible number of cases. There will not be any other case which will satisfy this condition. Okay, that condition is at least one ball of each colors. Okay, we cannot do this part, we cannot consider this part. Okay, we cannot. So now we have to see in how many ways we can do. So in how many ways we can select one red ball out of six? I can do 6c in 6c one ways, into for white ball I can do into 4 in c one ways, into for two ball I can choose two ball out two black balls. So we have total five black balls, so I can do in 5c two ways. Okay, plus for this part it will be again I have to choose one red ball, so it will be 6c1 into two white ball, it will be 4c2 into one black ball, it will be 5c1, plus two red ball, so it will be 6c2. I can choose two red ball out of six. Since we are not worrying about order here, it's not like this is the order, this can be anything, right? So this can be something like that, w r b and b. It can be b r w b, something like that. We are not worrying about order here. So here I have written like this. So just to mention one red, one white, two black, one red, two white, one black, two red, one white, one black. Okay, just to mention this part. So in this part, two red ball I have to choose, and one white I can do in 4c one ways, and one black I can do in 5c one ways. Okay, so 6c1 will be 6, 4c1 will be 4, 5c2 will be 10, plus 6c1 will be 6, 4c2, if we, let's solve this. So 4c2 will be 4 factorial, 2 factorial, 2 factorial. So 4 factorial I can write as 4 into 3 into 2 factorial, 2 factorial will get cancelled out, this will be 2, so 6. So 6 into 5c1 will be 5, then 6c2 it will be 6 factorial, 6 5 into 4 factorial, 4 factorial divided by 2 factorial. So 4 factorial will get cancelled out, and 2 times 3. 2 times 3 will be 6. So it will be 15. 6c2 will be 15 into 4 into 5. So it will be 240, and it will be 180. Okay, so it will be 180. And it will be next will be 300. So if we will add this, we will get 720, which is the answer for this question. So now we will see the third question. So this question says, how many 4-digit numbers without repetitions are there containing exactly two even digits by using the numbers 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so let's see the solution for this. So we have digits. We have digit 0, 1, 2, 3, 4, 5, 6, and 7. So we have total 8 digits there. So we have to form a 4-digit numbers. Alright. So to form a 4-digit number, First of all, condition is there should be exactly two even digits. So that means out of these four places, if there are exactly two even digits, okay, so that means for the remaining places there will be two odd digits. This, okay. Now, in how many ways we can do? So first of all, there are total, four even digits. You can see 1, 2, 3, 4. Okay, so 0, 2, 4, 6. These are the even digits, and uh, 1, 3, 5, 7. So these are odd digits. Okay. So in how many ways? First of all, I can choose two even digits. I can choose two even digits out of these four. I can do in 4C2 ways, and two odd digits I can do in 4C2 ways. Okay. So since we have to form a number here, order will be matters. We have to arrange the numbers, because if I will write 2, 4, 3, 5 or 2, 3, 4, 5, both are the different number. So here what we have done, we have selected two even digits, two odd digits. Now what we will do, we will arrange these four digits. So which we can do in 4C2 into 4C2 into, since we have selected total four digits, so I can arrange these in 4 factorial ways. So basically, if we will solve this, so it 4C2 will become 6. Okay, and again 4C2 will become 6, and 4 factorial is nothing but 4 factorial will be 4 into 3 into 2 into 1, so it will be 36 into 24, which is nothing but 864. But here we have to be little bit careful, because here what we have done, we have selected two even digits. If we are forming four digit number, so here 0 is included there, right? Suppose 0 is at the first place and we got number something like that. Okay, so this is not a four digit number. This is not a four digit number. This is the three digit number if 0 is at the first place. Okay, so here we have included the case of 0 also. So what we will do, we will, so basically this is the total ways to choose two even digits, two odd digit of four digit number. Okay, so to subtract so what we will do, we will subtract the case when 0 will occur at the first digit. So case we have to subtract when 0 will occur at uh, first place, or it will be basically when 0 will occur at first place, it will become three digit number. So we have to subtract those cases, and then we will get the four digit number. Okay, in which there will be two even digits, exactly two even digits. So what we will do, suppose so we have total four. So suppose 0 is fixed already, we know. Okay, we are going to consider this case 0 is fixed there. So what we'll do, as per the condition, we have choose exactly two even digits. Now 0 is an even number, and 0 is already there. That means we have to choose. So what we do, we have to choose a single even number. Okay, like because there can be exactly two even digits. So to choose the second one, and since 0 is already there, which I can do in 3C1 ways. Okay, so and remaining two places will be for odd digits, and that I can do in 4C2 ways. Okay, because anyway there are total four odd digits, and I have to choose remaining two odd digits. Now we have three numbers, one here, two here. We have selected three numbers, one here, two here. So now since this is the number, order will matter. So we will arrange. So we can arrange these three numbers in 3 factorial ways. So we will solve this. We will get 3 into 4C2 will become 6. 3 factorial will be, again become 6. So it will be 6 into 6, 36 into 3. It will become 108. Okay. So required ways will be, so this, when all cases are there including 0 minus we will subtract the case when 0 occurs. So 108, it will be basically 756. Okay, this will be the answer for this question. So we'll see the fourth question. A committee of 7 members has to formed from 9 men and 4 women. In how many ways can this be done when the committee consists of at most 3 women? Okay, so we will see the solution here. So questions is basically there are 9 men and 4 women. What we have to do? I have to form a group of 7 members. Okay, with the condition there's in this 7 members there will be at most 3 men. Sorry, 3 women. Okay, that means there can't be 4 women. Means we cannot select all 4 women for the committee, because condition is there at most 3 means till 3, not beyond the 3. So how we can do? Basically we can do like let's say we can say 0 women, 0. If we have 0 women, then we can do, that means we have to select means all 7 men. Okay, 0 women, 7 men. Then another case can be 1 woman. I'm writing W for women, and into 6 men, M for men. Okay, and another case can be, because you can see here a total committee of 7 members, again 1 woman, 6 men, then 2 women and 5 men, or another case can be 3 women into 4 men. And next case, if you write 4 women, so that cannot be case, because we have to consider the case at most 3 women. So now we will see in how many ways we can choose 0 women out of 4. We can do in 4C 0 into 7 men out of 9. So we can choose 7 person out of 9 in 9C 7 ways, plus 1 out of 4. So because there are total 4 women, so 4C1 for men it will be 9C6, plus 2 women I can choose out of 4 in 4C2 ways, into main I can choose out of 9 in 9C5 ways, plus 3 women I can choose out of 4 in 4C3 ways, and 4 men I can choose in 9C4 ways. Okay, let's solve this. So 4C0 will be 1, 9C7 we have to solve. Okay, so it will be 9 factorial divided by 7 factorial. 9 minus 7 will be 2 factorial, plus 4 into 9 factorial, it will be 6 factorial, and 9 minus 6 will be 3 factorial, plus 4C2 we know it will be 6, and 9C5 it will be 9 factorial divided by 5 factorial. 9 minus 5 will become 4 factorial, plus 4C3 will again become 4 into it will be 9 factorial divided by 4 factorial. 9 minus 4 it will become 5 factorial. Basically we have to do the simple calculation here. So what it will be, I can write this as a 9 into 8 into 7 factorial divided by 7 factorial into 2. So this 7 will get cancelled out, and this will become 4, plus it will be 4 into 9 into 8 into 7 into 6 factorial, and 6 factorial, 3 factorial I can write 3 into 2 into 1. So this 6 will get cancelled out here, this will become 3, and this will be 4, plus 6 into 9 into 8 into 7 into 6 into 5 factorial I can write like this, and 5 factorial in the denominator, and 4 factorial I can write 4 into 3 into 2 into 1, plus last part it will become again 4 into, so this is the this part, I mean this part, and this part will give you the same answer. It will be 9 into 8 into 7 into 6 into 5 factorial divided by 5 factorial, 4 factorial I can write 4 into 3 into 2 into 1. So here 5 factorial will get cancel out, 4 will get cancel out from here, it will be 3 and it will be 4. So here 5 factorial will get cancel out and it will be 4 times 2 8 will get cancel out, and here it will be 3 times 2 which will be 6, and here we can see some cancellation and all we have seen. So now it will be 9 into 4, we will see the write the remaining part, and it will be 4 into 3 into 4 into 7 plus here it we have 6 into 9 into 7 into 2. All right, we have then here 3 into 4 into 7 into 6. Okay, so basically we have to solve this part. Okay, so we have to solve this part. So what we will get, so 9 times 4 will be 36 plus this part 4 into 3 into 4 into 7. So 4 into 3 into it will be 12, 4 into 7. So basically this will become 336, and next part 6 into 9 into 7 into 2, if you will solve it will be 756 plus next part 3 into 4 will be 12 into 7 will be 84 into 6 will be 504. So basically we have to add all these cases. So 504 plus 756 plus 336 plus 36 will be 1632, which is the answer for this question. Okay, thank you.